Okay, so if we're looking at 3D objects, we've kind of got this word, it's called polyhedron, or polyhedra is kind of the plural form. And these are sort of prisms, pyramids, and types of solids that we can see kind of create edges and have this like this base. Now, and again, I want to kind of clarify, we have edges over here as well, but notice that they are all kind of like circular. They're more of like the circle variety. So when we have sort of that type of base that has either a triangle or a rectangle, and it's got sides and edges to it, that's kind of how we can differentiate between the two. So if I'm looking at these examples, again, what I have to look for is the number of faces, vertices, and edges. So I'm going to say that this one is yes. So yes, yes, no. It looks like this would be a rectangular prism. So I have a base of a rectangle, and it's a prism. Whereas if I count over here, 1, 2, 3, 4, 5, 6, that's going to be a hexagon, and it's a pyramid. So I'm going to say a hexagonal pyramid. And this would just be a cone. So number of faces, let's see here. 1, 2, 3, 4. This is 6 faces. I'm just going to do 6F. Vertices, again, that means how many times do they come connect? 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to say 8 vertices. And then edges, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me double check. So again, if I were to just kind of go through, let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I actually have 11 edges. Let's jump over here. I'm going to make this just a different color so we can see it better. That's all right. All right, and then let's say faces. I have my bottom face, and then I have my 6 sides. So I'm going to say I have the bottom, and then each side is a face. So that's going to give me 7 faces. Vertices, let's see here. 1, 2, 3, 4, 5, 6, 7 as well. And my edges, 1, 2, 3, 4, 5, 6 on the bottom, and 1, 2, 3, 4, 5, 6 moving up. So that gives me 12 edges. Faces, I would say that this has 2 faces. Well, we're not going to do it because it's not a polyhedron. So Euler's theorem, not Euler, Euler, okay? The number of faces, vertices, and edges of a polyhedron are related by the formula F plus V equals E plus 2. So if I'm double checking, it looks like we need to relook at this first one. So I'm going to just erase some of this stuff so we can get a better picture. Let me just double check. Edges, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I was off by 1. So I apologize for that. Okay. The number of faces, so again, F plus V, if I look at the first example, F plus V equals E plus 2, 6 plus 8 equals 12 plus 2, and 14 does in fact equal 14. Same over here, 7 plus 7 equals 12 plus 2, 14 equals 14. So make sure you have this formula written down. Use Euler's theorem in a real world situation. House construction, find the number of edges on the frame of the house. So let's see here. I'm going to use his theorem. I'm going to separate this into two different shapes. So I'm going to have my, let's call this a rectangular prism. And then I'm going to have my rectangular pyramid on top. And then that's going to help me figure it out. So if I just think about the rectangular prism, so again, I'm looking for edges. Well, I know that a rectangular prism has 1, 2, 3, 4, 5, 6, 7, 8 vertices. So I'm going to do 8, and then it also has 1, 2, 3, 4, 5, 6 faces. So again, that's my bottom one. And then if I look at the top one, I have 1, 2, 3, 4, 6 vertices and 1, 2, 3, 4, 5 faces. So 14 plus 11, I know that this example, again, using F plus V equals E plus 2. Actually, let's double check. So again, if we're going to substitute this in, right here, we have to say, all right, if that equaled 14, 14 equals E plus 2, that means my edges is actually 12. Same thing over here. If my faces plus my vertices equaled 11, then I'm going to have to say that my edges equal 9. So 12 plus 9 gives me 21 edges. Find the number of faces, vertices, and edges of the regular octahedron. Okay, check your answer using Euler's theorem. So let's see here. Faces, vertices, edges. Just by counting 1, 2, 3, 4, 5, 6, 7, 8. That square in the middle does not count because it's on the inside. Vertices 1, 2, 3, 4, 5, 6. And if I count edges 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I get 12. So 8 plus 6 equals E plus 2. 14 E plus 2. Looks like we got the same answer. Describe the shape formed by the intersection of the plane and the cube. So again, if this cuts it in half, this gives me a rectangular prism on top and a rectangular prism on the bottom. So I have two rectangular prisms, one on top and one on bottom. Whereas if I look at part B, when I slice it in half like this, I get a base of a rectangle, but this is actually forming a pyramid. So I would say that this is going to give me two rectangular pyramids. And looking at this last one, I'm slicing it. It's not cutting it exactly in the middle. So I have one base. I have one base that's longer than the other base. So this is going to be a trapezoid. So I'm going to have a trapezoidal pyramid on the top, on one side, and a trapezoidal pyramid on the other side. So two trapezoidal pyramids.